Hello, I'm Barbara Tharp.
And I'm Deanne Erdman. We're from Baylor College of Medicine Center for Educational Outreach.
Today we're going to look at the second activity in the series, The Science of Microbes, called Magnification Tools. This activity addresses the National Science Education Standards, both in inquiry and the science of technology. We look at the tools needed in order to study microbes, being as if they're so small. We're going to plan ahead. And to plan ahead, we're going to get the materials ready on trays for groups of 4 students. Definitely, we feel that doing it in groups of 4 is a nice way to do it for several reasons. One thing is classroom management. Another thing is to use less materials. What else do we think about?
Well, as you begin your school year, you definitely want to start training your students to be able to work in groups. Managing activities sometimes can become a problem if students don't all have a job and know that they're responsible for it. And so if you look in the guide, there's a very nice layout of where maybe one person might be the materials manager, one person might be a recorder.
One is the principal investigator and one is the maintenance director, and after a while they get familiar with their jobs, and for instance the materials manager always gets the materials. The maintenance director does not always clean up but always makes sure that it is cleaned up. The principal investigator hopefully will lead the experiment or investigation, and the reporter makes sure that things are recorded and that the teacher knows when they're done. With all that in mind, the materials manager knows when it's time that they go and get the materials for their group. Today we're going to look at the materials that we have on our tray, and we suggest, if you can, to put them on a tray. It makes for easy distribution and also to bring them back. Looking at this, for instance, today we have rulers and scissors, and we're going to need index cards and tape, some little items to look at: wax paper, droppers, magnifiers, slides,
microscope slides, some lenses, hand lenses, water with a little bit of a dropper, and we'll also need a microscope. And what's convenient about bringing all your materials together like this is that it also gives students a way of organizing the materials to bring them back in the same organized manner that they were distributed. And that way, if you have several different classes coming in doing the same activity, you're not scrambling trying to get ready for the next class. Everything's organized, and that's the way it should be. So the next thing that we want to do is to think about safety. And most of the activities that we do don't have any unusual kinds of risks, but you always want to make students aware of something even as simple as if water spilled on the floor, that's an easy time for somebody to slip. And you want students to realize they have to follow instructions and that they don't begin an investigation until you give them the instructions. And always we want to wash our hands after we're finished, because we don't ever know what we might have come up against. In this particular activity, we are using microscope slides, and while you can get plastic ones, you also some of these can be glass, so you would want to avoid the danger of cutting. And if a slide's broken, you know that you don't throw that in the trash can. You need to collect all your glassware in some sort of a container and then tape it and dispose of it in a more secure manner, because the custodian or anyone handling that trash could become cut. All right, so the first thing that we want to do is we want to kind of focus the students' attention on what our activity is today.
Okay, and since we're looking at microbes, and they now understand that microbes, because it's micro, it means it's too small to be seen with the naked eye in most cases. And with that in mind, one of the first tools they might look at or use would be the magnifier or hand lens. And with the magnifier or hand lens, we want them to look at different small items. We have a coin, and we have them look at the coin and really look at it and see, if I look at it like this, what do I see with the naked eye, and how does it change when I look at it through the magnifier? Maybe I want to look at
here we had just a little piece of some plastic that was left over from a craft project, and when I'm looking at it with my eyes, I can see the stripes in there. But when you're looking at the lens, can you see something else, Barbara?
Oh, I see a lot of corrugated edging, and even it almost looks wavy. So there's a lot to be seen, and I'm not sure that the students always understand what real observation is, and that means just going past okay, I saw it, to really taking a close look, and the magnifier is a nice way to do that. Okay, after they've looked at various objects, have them take a piece of newsprint, and with that newsprint, want them to examine very closely the lettering. get it in focus best they can, and then I want them to record what it looks like or draw what it looks like based on using the hand lens.
Does it look? When I'm looking at it this way with just my eyes, the ink looks pretty solid. How about with through the hand lens?
You start to see little dots. And there's a lot more color to it for some reason as well. So they see it definitely in a different light.
Okay. And so then the first thing that we want them to do is on their observation sheet, we would want them in the first area to record that they're using a hand lens and what they're looking at, and then maybe make a verbal description of what they're seeing, and then a kind of a detailed drawing. And we realize that every student's not an artist, but there's a difference between not being an artist and just being careless and sloppy. And that's something that you want to get across to your students, is that everybody can do a good job and show effort, even though they may not be as artistic as the next person. So we're going to do that as our first point of comparison.
Okay, so once we have drawn it using just the magnifier to enlarge the print, we're going to look at making a different kind of magnifier. So what we're going to do is use just a plain index or note card, and with the index or note card, I'm going to have them folded in half. So I folded this one in half, and then I want to find the center, going on the vertical like this, so then I pinch it right there. Then I have the center of the card. Now with the center of the card, I want to cut a 2 by 2 centimeter square. So to do that, the first thing I'm going to do is measure it. And when I look at, I want to cut it 2 centimeters this way and 1 centimeter this way. So I'm going to cut it out. And I start with a little square. Okay, once I have that square, I want to cover that square with wax paper. So I'll take a small piece of wax paper. We said 3 by 3 centimeters, but just as long as it covers the 2 by 2. And we're going to tape it on both sides. Thank you. Okay, now I have a little window. Now I ask them to look at the newspaper through the window. And when they look at it through the window, what do they see? What do you see there?
Well, it maybe just looks a little bit cloudy from the wax paper, but I don't see, it's the same size.
It's not magnifying anything, is it?
No, it's not.
Okay,
and I'm looking and I go, well, what's different about this versus the lens I just looked in? What do you think?
One's very flat. This is very flat, and this isn't so flat. So.
Oh, this has a curve to it. When I feel that, I can feel a curve on both sides, actually.
I think that's called convex. Okay. Now I'm going to do. Let's see. Yeah, you can see it right there. I'm going to put a drop of water on my wax paper, a nice fat drop. Now I'm going to look at that. Look at my newsprint through my fat drop, and what happens?
Oh wow, it's magnified.
It magnifies everything. So I've made a magnifier just with a piece of cardstock or index paper and wax paper and a drop. Now what I want to know is, what does the drop and the lens have in common?
Obviously, this one, when I look at the side of it, the drop of water is curved, from one of the cohesive factors of water.
Right, so we have convex here with a shape, and we have convex on here. So something about the rounded shape makes for the magnification.
Right, and so I think that that's called refraction, and the light is bent as it passes through the glass.
Certainly, and so as it passes through the glass, it refocuses and makes it look much larger. So we've just looked at a lens, a hand lens, and a water drop lens, and now what we're going to do is we're going to look at, first we'll record it, so what it looks like, what the newsprint looks like with the magnifier or hand lens, and then with the water drop lens, and describe how it looks, how it's similar and different with the water drop lens. Then we're going to go on if we're going to take a look at the compound microscope. So I don't know how many of you are lucky enough to have your own set of microscopes in your classroom. And if you do, it's certainly
nice for you to have one microscope per group of 4. But I've certainly been in teaching situations before where I didn't have the luxury of having that many microscopes. And so even if I had 1 or 2, you can set up stations in the classroom where students can rotate through. You can have a station where they're looking at things through the hand lens, a station where they're looking at things and making the magnifiers, and a station where they're looking at the compound microscope as well. So as we take a look at it, and you're looking at it, the reason it's called a compound microscope is there are 2 lenses. You have a lens up here and a lens down here in this rotating nose piece. And you might be surprised that the students can name some of the parts for you if you just kind of describe them to them. For example, if I ask where the stage was.
This looks like a stage.
That's a stage, and of course that's where you put your slide. And then a course adjustment knob, which moves the stage the most. Would you guess it to be the big or the small knob?
I think it'd be the big one.
The big knob.
Yeah,
and so obviously that moves the stage up and down closer to the object. Then we have the eyepiece, and this is called a rotating nose piece, and each one of these are objectives. There's a light source that comes in through the base that's going to illuminate our object. It comes right through a hole that's in the center of the stage. Now then, when we are viewing different kinds of things underneath the microscope, we want to do what's called a wet mount. And I'm going to take a plain, clean slide. I'm going to take a small cover slip, and I will put the slide down usually on something absorbent like a paper towel. And in order to get the cover slip to adhere properly and also to make the optics work properly, we're going to put a drop of water. I'm putting a couple because this was sort of a big piece of newsprint. And I'm going to take my slide and I'm going to put it on at an angle. And the reason I'm going to put it on an angle is I'm going to hopefully try not to get any kind of a water drop. So now I've got a temporary slide where I've got the material that I'm going to be looking at, and in this case it's newsprint, and it's covered by a protective cover slip which is going to protect my optics on my microscope. Right, so the next thing that I'm going to do is to put it on and focus. You know, Barbara, there's the 2 biggest mistakes that students make over the years when they're trying to focus the microscope are they try to start out with with looking at too small an area. They want to go to high power right away. They want to see, you know, all of the little minute detail. And the other thing that they do is they don't remember to keep centering their object that they're looking at. I kind of look at it as, you know, if I gave you a map to my house, and I just cut out a little tiny square about like this newspaper, and I handed it to you and said, you're invited to a party at my house, would you feel very welcome?
I don't think so.
And let's assume that, you know, this isn't the day of where you can just Google it or put it in on MapQuest. So you're not going to have any idea what part of town I live in. However, if I start with a large map and I show you the big crossroads, and then we narrow in and we look at a little smaller area and then a little smaller area, then you're going to get a pretty good idea of what we're talking about. And you want to do the same thing with the microscope. You want to start out and you want to look at the biggest area you can, so you always want to start on low power. So that's the first thing that we do is we put the objective on low power. We center it because obviously if it's not centered, and this is a mechanical stage so I can move it very easily. If you just have traditional stage clips, then you can you slide that around. It just the same. It works exactly the same way. And I've got my lights, and I'll have my light source on, of course. And I'm going to look into the microscope, and I'm going to use the coarse adjustment. I'm going to bring the object as close as I can to that objective. Now you notice it's much shorter compared to the rest of them. I'm in no danger of breaking my slide because there's a lot of distance there. So I bring it all the way up. I slowly start down, and someplace right in there it's going to come into focus. I check it with my fine adjustment. I get it real sharp, and then I'm going to center it. Because if I don't, it's just like looking at this camera. If I don't move to the center of the camera before I move in, if I keep going closer and closer and closer to the camera, without getting in front of it, I'm going to be out of view pretty soon. And the same thing happens on the microscope. So we get it centered. And then if we think we'd like to look at it at a little higher magnification, we move to the middle magnification.
Well, can you tell me a little bit about the magnification? I see numbers on the different objectives. What do those numbers mean?
The numbers. This one says 4 on it, and this next one says 10. And the last one says 40, and that's how many times they magnify. Then on the top, it says 10 up here. So what do you think? Should I just add them together, 10 plus 4 or 10 plus 10? Or what do you think I do?
Multiply them together, maybe?
You multiply them together, so that really gives you a lot of power. So when I had it back using the shortest objective, 10 times 4 means I was magnifying it
40 times.
40 times. So.
And Deanne, did you notice that the way that students might remember that is that X means times, and so most of the microscopes have an X on them, so that's what they can remember, to take one times the other one.
Yeah, I think that's a great tip, because and having little helpful memory tips like that, there's not anything wrong with it all. So now I've got it on 10, and I'm still using my eyepiece up here that's set at 10. So now I'm looking at it 100 times magnified. And I'm going to look at it, and as I'm looking at this newsprint, it's quite a bit different than I thought it was going to be. And I'm only using my fine adjustment, remember, because it's very close in focus, and I don't want to crush the slide. It's really not solid at all. The paper looks fibery. The ink is not solid. So I'm seeing a lot of difference. So
can you record that on the?
I think so. That's what we'd want to do next, is to record this on the student sheet and make our additional
and then
notations.
they could compare the 3 different observation 1, 2, and 3 and see what this magnification does. And what is the top magnification we're going to look at with the microscope, do you think?
In this case, you can go all the way up to use the highest power, which in this microscope is 40 times 10, which would be 400. But many microscopes that you have in the classroom may only go up to 200. Okay. So in this particular case, you're looking at something that's thin. You're going to be able to easily pass light through it. So I think you can go as high as you want. You're not going to see that whole letter E anymore, and I think that's an important thing for students to talk about, that they couldn't see the whole thing as they got.
Not even one letter.
No, not even one whole letter.
And before, with the magnifier, you could see a lot more than, and with the water too, you could see a lot more than just one letter.
Absolutely.
So that's a real good way to demonstrate magnification.
Right, and that you're looking at just a tiny little surface. Another thing, as they're comparing it, that they saw increased detail. They saw that it really wasn't solid, like it looks like when you're looking with your unaided eye, that it's really kind of blotchy looking. So they begin to get a little bit of an idea of the detail that you can see with increased magnification.
The only other thing I would think is to have them look at the fact that what happened with the hand lens, what happened with the water, and what happened with the microscope, all of them is because of the lens and because the lens being curved. So that's what they all have in common.
Mm-hmm. Yeah, and I also think it's important for students to realize, when is the appropriate tool needed. For example, if I brought in a little cricket or a little beetle and we were looking at it, it's certainly not going to be appropriate for me to try to get that thing underneath the microscope, and I'm not going to see anything. So the appropriate tool in that case might be something as simple as a hand lens.
Certainly.
So it doesn't always mean that you've got to have the fanciest, most sophisticated tool, but you've got to choose the proper tool for the correct job.
And that takes experience with all of them.
With all of them, correct. One thing about the history of lenses, it's interesting that science is often tied to technology. And we're seeing that today in the field of genetics. We're having a lot of new breakthroughs, and it's tied to our new sophistication and our new technology. The same thing was true back in the 1500s and the 1600s. You can imagine trying to talk to people about things that were too small to be seen, or that say that ink really wasn't solid, if they had no way of being able to see it. Mm-hmm. So Zacharias Janssen in 1595 was the first one to come up with a compound microscope, and we now know that compound means that it has 2 lenses. and it let them have this increased ability to be able to see at a much greater magnification. He was originally a Dutch spectacle maker. They called your glasses would have been spectacles in that time period. Robert Hooke in 1665 was the first to observe plant cells, and he was looking at cork, and he was the person who named cells. And then Anton van Leeuwenhoek, who also was a Dutch merchant, who I believe you said that he was
a drapery maker.
He was a drapery maker, and he wanted these lenses to be able to look at the quality of the cloth that he was using, because he made very fine draperies for important households, and he wanted the fabric to be just so. And so he invented a microscope that actually magnified up to 200 times, which was pretty significant for that period of time. He's also the first one to look at pond water, and boy, was he surprised when he looked in there. And just as surprised as your students are going to be later on when they get to look at pond water. He was the first to observe the protist, what we now call protists and bacteria, and he called them animalcules. So we've got a lot of fun to look forward to. The microscope is a really valuable tool in the classroom, and I think sometimes we can get carried away with technology and fancy equipment, but don't overlook that microscope. And if you'd like to learn more advanced techniques on good microscopy, we have a number of presentations on BioEd Online, and those are listed for you on the slide.
Thank you.